By the end of this video, you will learn why cell balancing matters and how it actually works in a battery energy storage system, or BESS. Imagine 10 cells, all starting with equal voltage and state of charge. In real applications, these voltages are allowed to vary slightly within a tolerance band set by the battery management system, or BMS. Over time, small differences appear. As long as they stay inside the tolerance band, no problem, no balancing is needed. But eventually, some cells drift too far apart. Once they move outside that tolerance band, the BMS steps in, and cell balancing begins. Now let's zoom in on just 2 cells to see why cell balancing matters. Take cell 3, it has a higher voltage and a higher state of charge. And cell 4, it has a lower voltage and a lower state of charge. The battery management system, or BMS, keeps a close watch on each cell's voltage. Its job is to make sure every cell stays within safe voltage limits between the maximum voltage limit, Vmax, and the minimum voltage limit, Vmin. If any cell goes beyond these limits, it can damage the battery or even cause safety issues. During charging, cell 3 reaches its maximum voltage limit, Vmax, before cell 4 is full. The BMS stops charging to protect cell 3, leaving cell 4 undercharged. During discharge, cell 4 reaches its minimum voltage limit, Vmin, before cell 3 is empty. The BMS stops discharging early, leaving cell 3 with unused energy. Repeatedly operating cells at Vmax or Vmin not only wastes capacity but also accelerates cell degradation. That's why cell balancing is essential. It ensures safe operation, keeps cells healthy, and lets the battery deliver its maximum usable capacity. Now that we understand why balancing is needed, let's explore how it's actually done. There are 3 main methods of cell balancing: passive balancing, selective charging balancing, and active balancing. In passive balancing method, the BMS sets the tolerance band to the lowest voltage cell. All higher voltage cells outside this band, for example, cells 3, 5, 7, 8, and 9, are discharged through resistors to remove excess energy. It's simple and widely used method, but inefficient because that extra energy is lost as heat. To reduce that loss, there's another approach called selective charging balancing. Here, the BMS sets the tolerance band to the highest voltage cell. Low voltage cells outside this band, like cells 1, 2, 4, 5, 6, 9, and 10, are selectively charged until they are back in tolerance band. This method saves more energy than passive balancing, but it's more complex to implement. For maximum efficiency, we turn to active balancing method. In this method, the BMS transfers energy directly from high voltage cells, such as cells 3, 7, and 8, to low voltage cells like cells 4 and 10. No energy is wasted as heat, but the circuitry is more advanced and costly. So whether it's passive or active balancing, the goal is the same: to keep all cells balanced and working at their best. When all cells stay balanced, the battery can use more of its stored energy, run safely, and last much longer. That's the real power of cell balancing. If you found this helpful, don't forget to share and subscribe. See you in the next video.